defect. So what is meant by mass defect? Yesterday also I think we have had a small discussion on this one. See, so if I take mass of nucleus, nucleus means it contains protons and it contains neutrons. So I take the mass of nucleus. Are you able to understand? Then after that, then I will take the mass of individual nucleons. What is meant by nucleons? Protons and neutrons, they are called as nucleons. So individually, if I measure the mass of nucleons, or if I take combined mass of nucleus, then I see that combined mass of nucleus is always less than if I take the mass individually. So some mass has disappeared when nucleus has formed. So that disappeared mass itself is called as mass defect. Are you able to understand? See, for example, how can I calculate mass defect? Delta M can be written as, so Z into mass of proton plus N into mass of neutron, if you add both of them individually, minus of total mass of nucleus. If I take, then always there will be some difference. That difference is nothing but mass defect. Are you able to understand? Now can you say what is meant by Z into MP? MP means mass of protons. Clear? Z into MP means? Z means number of protons, not atomic number. So you take the total mass of individual protons separately. Okay, we know what is the mass of one proton, no? 1.0078 atomic mass units. That is the mass of one proton. So you take the mass of all the protons and you take the mass of all the neutrons. So N is number of neutrons. M is number of mass of the neutron. So you take the masses of individual nucleons. Okay. Then you take the mass of combined nucleus. Okay. Then I see that this mass is always greater than combined mass of the nucleus. Are you able to understand? It means when these particles, when they combine to form a nucleus, some mass is disappearing. Some mass is completely disappearing. That disappeared mass is nothing but mass defect. Are you able to understand? So now first of all make a note up to here. చెప్పేటప్పుడు రాసుకుంటా ఉన్నారేంది మీరు? చెప్పేటప్పుడు వినాలి కానీ రాసుకుంటే ఎట్లా? In helium nucleus, how many protons are there and how many neutrons are there? So there are 2 protons and there are 2 neutrons. Are you able to understand? So what I do is, so mass of individual particles I will take. Mass of individual particles. What is meant by mass of individual particles? So 2 into mass of protons plus 2 into mass of neutrons, because there are 2 protons and there are 2 neutrons. Okay. So let us call it as total mass as M1. Are you able to understand me? Then what I will do, I will take the mass of helium nucleus. Okay. So inside helium nucleus also we have 2 protons and 2 neutrons only. No? Okay. Now take mass of combined nucleus. Okay. And let its mass is M2. So actually we believe that M1 and M2 they should be equal. No? Mass of individual particles is M1, 2 protons plus 2 neutrons. Combined mass is M1. And if you take mass of nucleus, nucleus of helium also contains 2 protons and 2 neutrons only. No? So its mass is M2. But when I check their masses, I always see that M1 is greater than M2. Individually if you take masses, then it is M1. Nucleus lo kuda ave untayi kada, inside nucleus of helium also you should have 2 protons and 2 neutrons. Mari masses same ga undali kada. Are you able to understand? But I see that the individual masses, that is if I take the masses of protons and neutrons separately, then it is always greater than when the same protons and same neutrons when they combine to form nucleus. Nucleus form అయినప్పుడు వాటి masses M2 గా ఉంటుంది. And I see that M1 is always greater than M2. Okay. So this difference of M1 and M2, this difference is nothing but mass defect. Okay. So what happened to that remaining mass? that remaining mass, it has been converted into energy. Are you able to understand? So therefore what I say, this mass defect or reduced energy, reduced mass, okay, has converted into what? Has converted into energy and is being released. Okay, that mass has been converted into energy and it is liberated. Okay. See, whenever particles, when they lose some energy, they become stable. Are you able to understand? This is not the property of just nucleons only. This is the property of any body in this universe. If body has more energy, it will become more unstable. So when some of the mass has converted into energy, and when that energy is liberated into the atmosphere, then the same nucleons, they will become stable. Are you able to understand? See, inside the nucleus, 2 protons are there. No? Protons are which kind of particles? Positively charged particles. So one proton is present beside another proton. Rendu protons oke chotu unnai kada. So even though there is a very strong force of repulsion between them, between one proton and one proton, force of repulsion untundi kada. So even though there is a lot of force of repulsion, but still they are present at same position. It is only because of this mass defect. Are you able to understand? Some of the mass has converted into energy and it is released. So when these protons and neutrons, when they lose some energy, by converting some of their mass into energy, they become stable. Are you able to understand? So stability is obtained only because of release of energy, when they lose some energy. Okay, let us try to understand this one in general terms. Clear, ma? Jyoti ki ₹1 crore ichna. I have given 1 crore of rupees to Jyoti. Evaru Jyoti meelu? Clear, ma? పొరపాటు అయిన క్లాస్లో కూర్చుంటుందామా? She'll never sit in the class. Are you able to understand, ma? She will become more and more unstable. Okay? సంవత్సరానికి లేదా వారానికి ఒక రోజు క్లాస్కి వస్తుంది, మిగతా రోజులు మట్క ఆడడానికో లేదంటే క్రికెట్ బెట్టింగ్లకో ఏదో ఒకటి వాడుకుంటుంది అనమాట. క్లియర్ నౌ? షీ విల్ నెవర్ బీ ఇన్ ద క్లాస్. ఓకే, బట్ ఆఫ్టర్ టోటల్ 1 crore of rupees is completed, then what she will do? She will become more stable and మర్యాదగా వచ్చి క్లాస్లో కూర్చుంటుంది అనమాట. క్లియర్ నౌ? Same concept is happening with the case of these nucleons also. When they have more energy, they are unstable. So what they will do is, they have to release some energy. And how they can release energy? Because Einstein said that mass and energy, they are interconvertible. No? So they will convert some mass into energy and they will release that energy. Once they release that energy, they will become stable. Okay, ma? So the mass of nucleus is always less than mass of individual particles. Okay, that defect in mass, that reduction in mass is nothing but mass defect. Is it clear, ma? Come on, make a note up to here. Okay, here we have taken the example of a deuteron. What is meant by deuteron? So isotype of hydrogen. Hydrogen 1,1 is called hydrogen. Hydrogen 1,2 is called as deuteron, and hydrogen 1,3 is called as tritium. Are you able to understand? Sima. So in hydrogen 1,2, 2 means what? There is 1 proton and there is 1 neutron. That's all. So what is the mass of neutron? 1.008665 atomic mass units, and mass of proton is 1.007825 atomic mass units. So if you add the masses individually, this is the mass you will get. Are you able to understand? But if you take the mass of deuteron nucleus, are you able to understand, ma? I am taking the mass of deuteron nucleus, then how much it is? It is 0.014103 atomic mass units. So definitely this value is less than this value, no? Here I have 0.014, here I have 0.16. Okay, so nucleus mass is less than individual masses of the nucleons. So therefore what is the mass defect? So this value minus this value, so this is the value which I got. Okay, So therefore what is this mass defect ma? It means that this much amount of mass has disappeared. ఇంత మాసు న్యూక్లియస్ ఫామ్ అయ్యే ప్రాసెస్లో మాయమైపోయింది. able to understand? So this is the amount of mass which has disappeared when this nucleus was formed. Are able to understand? So this mass I can convert into energy also nama, by using which relation? By using Einstein's equation of mass energy equivalence. E is equals to mc square. Delta m is nothing but mass disappeared. Okay, and what is the mass disappeared? This much amount of mass has disappeared. So 0.002387 multiplied by, see already we studied that one atomic mass unit, if it is converted into energy, it releases 931.5 million electron volts of energy. This already we have studied, no? The last class we studied, no? One atomic mass unit of energy, if it is successfully converted into energy, one AMU of mass, if it is converted into energy, then it releases this much amount of energy. So here also I am writing in AMUs only, no? So just to multiply that value by 931.5, then this is the amount of energy which was released. 2.2 million electron volts of energy is released when this much amount of mass has disappeared. ఇంత మాస్ మాయమైపోతే అంత ఎనర్జీ రిలీజ్ అయింది. ఓకే, అండ్ దిస్ అమౌంట్ ఆఫ్ ఎనర్జీ రిలీజ్డ్ ఈజ్ నథింగ్ బట్ న్యూక్లియర్ బైండింగ్ ఎనర్జీ. ఓకే, వాట్ ఈస్ మెంట్ బై న్యూక్లియర్ బైండింగ్ ఎనర్జీ? Because this released energy is responsible for keeping the nucleons at one place. Energy కొంచెం వెళ్ళిపోయింది కదా, all the nucleons they will become stable. Some energy is released, so nucleons automatically they will become stable. So therefore this energy is called as binding energy nuclear binding energy. Okay, so therefore what is meant by nuclear binding energy? Nuclear binding energy definition, how I can write is, I can write like this. Clear, ma? So two definitions I will write. The energy released by which nucleons have combined to form a nucleus. This energy is called as nuclear binding energy. Okay, ma? The amount of energy released which is responsible for making these nucleons to be present at one place. Because energy వెళ్ళిపోయింది కదా, now they have to become stable. Clear, no? Or one more definition I can write is that, so if this amount of energy is given, clear, no? Then nucleons can be separated. Nucleons can be separated by infinite distance. Are you able to understand, ma? What is the meaning of this one? Previously energy released was 2.2, no? Same energy if I give to the nucleus of this deuteron, then what happens? Previously this much amount of energy was released. Now same energy if I give again to the nucleus of deuteron, then what will happen? Again they will get separated. Okay, previously all the nucleons they were in separated stage, no? Now if I give this much amount of energy, again the nucleons have the ability to get separated. Are you able to understand? So that is why this energy is also called as nuclear binding energy. Okay, ma? Same for nuclear binding energy I can write two definitions. Are you able to understand? That is binding energy per nucleon. Okay, ma? So what is meant by binding energy per nucleon? It is called BEN, ma. BE per N, or just you can call it as BEN, binding energy per nucleon. Okay, so BEN means what? Total binding energy divided by number of nucleons. Okay, that is called as binding energy per nucleon. For example, in deuterium, what is the deuteron, what is the binding energy I got? 2 point. Are you able to understand? This is the total binding energy for this total nucleus, no? Okay. So therefore total binding energy was 2.2 million electron volts divided by how many nucleons are there inside helium? Helium lopala nucleons annu untayi 4, 2 protons and 2 neutrons. So divide them by 4. So here whatever answer you will get, that is called as BEN, binding energy per nucleon. Are you able to understand ma? Ante okokka nucleoniki enta binding energy release ayindi ani artham. For each nucleon, what is the amount of energy released? That is called as BEN, binding energy per nucleon. Are you able to understand ma? So 1.1 by 2, 1.1 by 2 is how much? 0.55. That's all, no? So therefore I can write it is 0.55 million electron volts. Understood, number? So like this we have to calculate binding energy per nucleon. Now here, what is the importance of this binding energy per nucleon, that we will write down. This is the most important point in this topic. Okay, ma? So, importance of BEN. Okay. So, first of all, we will study fission, nuclear fission. Okay, ma? What is meant by nuclear fission? If two atoms of lower BEN combine to become one atom of higher BEN, okay ma, then energy will be released. Then energy will be released. Okay, and this process is called as nuclear fission. I said this is fusion, nuclear fusion. Okay. So in nuclear fusion process, in which condition energy will be released, ma? See here. If two atoms of lower BEN, two atoms, their binding energy per nucleon should be lesser. So such atoms, they should combine to become an atom of higher BEN. So rendu lower BEN unna atoms combine ayi edi create avvali? Higher BEN atom should be created. Higher binding energy means what? More energy is released, no? So automatically energy will be released. Are you able to understand? So this is the process of nuclear fusion. So which atoms should combine to become what? Lower BEN atoms should combine to become higher BEN atom. Then energy will be released. Understood now? Then we write nuclear fission. Nuclear fission. Okay, ma? What is nuclear fission? Single atom of lower BEN, binding energy per nucleon, should split into two daughter nuclei of higher BEN, then also energy is released. Are you able to understand? So this process is called as nuclear fission. Okay. So in nuclear fission, what is happening, ma? So there is one single atom whose BEN value is lesser. So that should be split into two daughter nuclei, and each daughter nuclei BEN value should be greater. So if BEN is greater, it means more energy is converting into mass, no? So automatically energy will be released. So whether it is nuclear fusion or whether it is nuclear fission. Fusion means combination. Fission means getting separated. Are you able to understand? Whether it is a fusion or fission, which atom should convert into which atom? Lower BN should convert into higher BN. Then always energy will be released. Are you able to understand? So direct questions will be asked on this topic. Okay. So first of all, let us draw the diagram of different BNs of the periodic table. Come on, make a note of 2 here. Energy should be absorbed in that condition. Are you able to understand? If a higher BN should convert into lower BN, then energy should be absorbed. Energy is released only when lower BN converts into higher BN. Understood, Nama? That's it. So let us make a note of that point also. So what is the note point I have to write? Note point is that, okay, ma? Energy is always released. See, nuclear fission and nuclear fusion reactions, they are very powerful reactions. No, these are the reactions happening in the sun. So sun is releasing very huge amount of energy. How it is releasing? Because it always converts to lower BN atoms into higher BN atoms. That is the process which is happening in the sun. Are you able to understand? So energy is always released, okay, when lower binding energy per nucleon atoms convert into higher BEN. So this is the most important point in this BEN concept. Understood, Nama? So Sima, this is the binding energy curve. We have represent all the important elements here. Okay, now see. So on the x-axis we are taking atomic mass, or you can say mass number. Okay, on x-axis mass number 20, 50, 75, 100 like this. Okay, and on y-axis we are taking binding energy per nucleon. BEN I am taking, and BEN I am taking in million electron volts or mega electron volts. Clear? Now see. So hydrogen, mass number 2, this is having the lowest BEN. Hydrogen is having lowest BEN. Then followed by tritium. This is a deuteron, this is tritium. Then here I have lithium, helium, then nitrogen, carbon, oxygen 18, oxygen 16, sulfur 32, iron 56, molybdenum 100, like this I have. Are you able to understand? See, out of all these elements, which is having highest BEN? Iron. Highest BEN is existing for iron, nearly some 8.8 million electron volts. Okay. Highest BEN means what? Highest BEN ante meeku em arthamavutundi? What do you understand? It means more energy has been released, no? Binding energy is greater means that more mass has converted into energy. So it means most of the energy has released. Ekku energy release ayindane kada. Okay. So therefore if most of the energy is released, that particular element will become most stable. Okay. అంటే మీ కాడ డబ్బు లేకపోగా అప్పుల పాలైనారు అనమాట మీరు. అర్థమవుతుంది కదా, మర్యాదగా ఇంట్లో కూర్చొని ఉంటారని అర్థం. Are you able to understand? So if binding energy per nucleon, if it is greater, it means it has lost more energy. It means more mass has converted into energy. Are you able to understand? So therefore the element which has highest BEN, it will be always more stable. So of all these elements, iron is the most stable element. So అందుకే ఐరన్ అంత అద్భుతంగా ఉంటుందన్నమాట. It is most stable because its BEN value is largest. Similarly, elements with atomic number less than 30 and greater than 170, they are unstable. Are you able to understand? Because their BEN values are lesser, less than 8. See, most of the atoms starting from 32 up to approximately 170, Okay, this is here we have 32, no? And here we have 170. All of them, they are above 8. They are above 8, no? BN 8 pine unnai. Elements from starting from here to here. And these elements in between 32 and 170, they are having BEN of 8 and they are most stable. Okay. So elements with atomic number less than 30 and greater than 170, they are not so stable. Are you able to understand? This is second point which we have to observe. And one more point is that, see here I have hydrogen. Okay. When two hydrogen combine to become helium, this is the process which is happening on the surface of sun. Suryulo jarugutunna process. Okay ma? When two hydrogen, when they combine to become helium. Okay. So hydrogen is having lowest BEN. Hydrogen BEN is very less. But you see the BEN of helium, it is very large. Okay. So lower BEN, when it converts into higher BEN, energy will be released or absorbed? Energy will be released. So therefore, when two hydrogen, when they combine to become helium, very huge amount of energy will be released. Are you able to understand? Ma? Similarly, and this process is called what? Nuclear fusion reaction. Two hydrogens, they are getting fused and helium is formed. Okay, lower BN converts into higher BN. Similarly, if you see here uranium 92, okay ma, it can be split into barium and krypton. Okay ma, barium mass number is how much? Barium atomic number is how much ma? It is 56 and krypton it is 36. Okay, now see. So uranium atomic number is 92, but mass number is how much? 238. Are you able to understand? Ma? When they convert into barium and krypton, this is which kind of process? This is fission process. Are you able to understand? Ma? And uranium has lower BEN, barium and krypton they have higher BEN. Are you able to understand? Ma? So when this converts into higher BEN, here also energy will be released. Are you able to understand? Ma? So those are the note points here which I have written. Element with highest BN is most stable. So iron is the most stable. Okay, ma? Except with the lighter nuclei. Lighter nuclei means what? A value less than 30. Mass number if they are less than 30. Then average binding energy per nucleon is about 8 million electron volts. Okay. It means the elements in between mass number 30 and 170, they have an average BN of 8. Okay. So nuclei with A is equal to 60 have highest BEN and they are most stable. It means the elements which are present in this region, they are the highest, highest BEN is present, so they are most stable. Okay, whose mass number is around 60. So BEN is less for both A is equal to A is less than 30 and A greater than 170. So these are the points which you should remember. Okay, ma? So whatever it may be, what is the condition here we have to study? If elements of lower BEN converts into elements of higher BEN, then energy is always released. That is the point which you should remember. Okay, that's it. Make a note of